in terms of law of sines for quizzes and tests moving forward is I will always give you this formula, and then we'll do the law of cosines on the next time I see you, and I will always give you that formula as well. Law of sines and law of cosines is not hard if you have a formula and you know where things go in the formula. So rather than make you memorize the formula and know where everything goes in the formula, we're just going to make you know where things go. Okay, so I will give you the formula. You don't need to memorize it. It's on the test for you. On, I can't remember if it's quiz or test. I will give you a formula. I don't tell you it's the law of sines, but here's the beautiful thing. The law of sines, guess which trig function it uses? Oh, sine, yes. And the law of cosines, guess which trig function it uses? Cosine. So you'll know, even though I don't necessarily specify which one is which, if I say use the law of sines to solve for da-da-da-da-da, and you see a formula that has just sine in it, that's probably the one, right? Okay, so law of sines. We're kind of moving in a new direction today because so far all we've done is right triangles. This is not for right triangles, okay? This is for any triangle that you can use the law of sines. So here's what the law of sines says. For any triangle ABC, let the lengths of the sides opposite angle A, B, and C be lowercase a, b, and c. And that's what we've done so far already. So that's not new, right? We're just saying A is across from A, B is across from B, C is across from C, okay? Then the law of sines relates the sine of each angle to the length of the side across from it. So we're basically just setting up a proportion, okay? We're saying the sine of A over A, okay, so capital and lowercase matters here, right? Sine of capital A, sine of the angle, over the side across from it, lowercase a, will equal the sine of angle B over a lowercase b, which will equal the sine of angle C over a lowercase c, okay? Here's where I don't want you getting so tied down to letters though, okay? I typically, as a formula, am just going to give it to you like this, just because that's how you're going to solve it, is as a proportion with two fractions, okay? That doesn't mean that it's not angle C. It can be any of the angles with the side across from that angle, okay? So think of it that way. Angle B will always correspond to the side across from it, lowercase b. Angle C will correspond to the lowercase c, okay? When to use the law of sines. You can use the law of sines in 3 different scenarios, and these are the 2. When you know 2 angles and the length of a side. So if you have an AAS or an ASA setup, you can use the law of sines, okay? The other one is if you have 2 side lengths and the measure of the non-included obtuse angle, okay? So basically donkey, right? SSA or ASS. You may use the law of sines if you have that set up, all right? Now, I don't find myself determining how to use it that way. What I typically do is I will look at a problem. So like number 1 here, I'll go, okay, do I have an angle and the side across from it? I have an angle and I have the side across from it. I'll look at another one. Do I have an angle and the side across from it? Yes, I do. If you have that, right, with just one unknown, you may use the law of sines. So you can think of it either of those ways, AAS, ASA, or SSA, right? This would be angle, angle, side that we have. Or you can just think of it, do I have the angle and the side across from it, and an angle and the side across from it? That's how I like to do it. Okay, so rewind here. If I'm looking at this picture, and I know the sine of an angle relates to the side across from it, if I started by saying the sine of 28, what would I put that over? 11.4, okay? It's very easy for people to confuse this and say the sine of 11.4 over 28. But what have I always said about angles? They must go with the trig function, okay? So it's going to be the sine of the angle and the side across from it is the thing that will be by itself, okay? So we would say sine 28 over 11.4 is equal to, anyone think they can do it? Sine 125 over x, right? Here's my other angle and the side across from it. So you're just setting it up as a ratio, okay? And then putting those two ratios together to make a proportion. How do you solve a proportion? You cross multiply. So that's what we're going to do. We are going to cross multiply here. If I were you, I would always put the x out in front just because I feel like it stays by itself then, and that's what we want. Okay, so when I cross multiply this way, I would say x sine 28. Okay, that's going to equal, now we cross multiply the other way. And again, put the number in front of the trig function. So 11.4 sine 125. Okay. At this point, you have a couple options, okay? Do you know what we need to do to solve here? How do you get x by itself? You divide. Okay, so here's the issue with this. If we divide by sine 28 and divide by sine 28, typically your calculator is going to put a parenthesis here, but not here. And if you don't finish that parenthesis and want to plug it all in as one thing, you will get the wrong answer. So this is what I recommend. You either plug this part in, hit enter, and then divide by sine 28, then you have nothing to worry about, or you absolutely make sure that you put that parenthesis in. You have to do one or the other of those, okay? If you just plug it all in as one big thing, you're gonna get it wrong, for most calculators anyway. Okay, so try that for me so you can see how your calculator works with that. See what you get when you plug in 11.4 sine 125 divided by sine 28. And we'll see if you get the right answer. That's the one. Yep, you should be getting 19.9 to the nearest tenth. Okay, anyone not get that? This whole thing, 11.4 sine 125. Either hit enter at that point and then divide by sine 28, or make sure you put this parenthesis in, because your calculator is going to give you that one. So you need to finish it off. Otherwise, your calculator thinks you're taking the sine of 128 sine 28, and we don't want the sine of that. We just want the sine of 125. Anyone not getting it? If you're not getting it, talk to me at the end so I can make sure you know how to plug it into your calculator, okay? Because that's a bummer reason to get something wrong, is because you just plugged it in wrong. So make sure you're getting the right answer there. All right, number 2, set it up for me. What do we do here? It doesn't matter which one you do first, no. It's not x over 13, it's, no.
X sine.
Sine x, right. So it's the sine of the angle over the one across from it. Sine x over 13 equals what? Sine 43 over 9. Okay? Now this one is different. Notice can you see the difference in this one? This one we were solving for an angle. This one we were solving for a side length. What always gets used when we solve for angles? The inverse, okay? This one needs the inverse. So pay attention to that when you're solving for a problem. Am I gonna have to use the inverse on this problem? You will with this one. So if we cross multiply, I get 13 sine 43. You set that equal to, go the other way, and again, put the whole number out in front, 9 sine x. Okay, I don't want you thinking you're multiplying 9 times x. How would you solve this? What's your first step? You gotta do 2 things here. You need to get x by itself. That's not gonna work in one move. What's your first move? You wanna divide, right? Because this is a number. Sine x is a number. right? So right now we're saying 9 times sine x. Leave the sine x alone for now and just divide by the 9. Okay, so I get sine x equals this. Now, if I were you, I would plug this in, and again, you might want to do it in 2 steps because your calculator is going to start a parenthesis here. If you want to do it all in 1 step, make sure you end that parenthesis here. So 13 sine 43.
What does sine even like do to these numbers?
It's a ratio that gives you a relationship here.
Okay.
It's a set comparison is how we'll say it. Okay, here's what I want you to see. Your options are plug that in. Can you see that? Is that too small? If you plug this in, hit enter, and then divide by 9, you should be getting that number, okay? You're welcome to write that down, but I wouldn't even mess with that. I mean, you can, but go at least like 4 decimal places if you're gonna write it down and use that number. Here's what I would do. Fun little trick for your calculator, okay? Go second inverse sine, because now we have to take the inverse of that, right? If it's sine x, we take the inverse. So it's gonna be inverse sine of 0.9851. You may punch that in, but even easier and more accurate is now if you go second sine and then go second, mine is entry. Is yours your enter key? Oops, no, answer, not entry, sorry. Second sine, so the inverse sine of my last answer, ANS. You all have a button on your calculator that looks like that too. Have you used that before? You should, all the time. It's beautiful. So that's taking the inverse sine of my last answer, which is that number. Okay, so to the nearest degree, that would be 80 degrees. Sometimes we'll ask to the nearest tenth of a degree on these, so that would be 80.1 if we do nearest tenth. Just pay attention to what we're asking for. Sometimes it's nearest tenth, sometimes it's nearest whole number. But that's what you do with those, okay? When you get to a sine of x, take the inverse of whatever this equaled. Questions on that? Are we comfortable there? Can I move on, or you need a little more time with that? What? Good. Okay, last question. Hopefully we make it through. Says a ship has been at sea longer than expected and only has enough fuel to safely sail another 42 miles. Port City Lighthouse and Covetown Lighthouse are located 40 miles apart. Okay, so that's this 40. At sea, the captain can't determine distance by just looking at it. And it says the triangle formed is shown. Can the ship sail safely to either lighthouse? Okay, so could they make this trip or could they make this trip knowing what we know here? Okay, well, law of sine says you take the sine of an angle over the opposite side. Do we have an angle with a side across from it and another angle with a side across from it right now? We don't, right? But what could we find right now? The third angle. Okay, so sometimes it's gonna look like you don't have enough info, but if you have 2 angles, you can always find the third. So our third angle here, you would just do 180 minus 52 minus 70, and your third angle will be 58 degrees. Okay, so this is 58 degrees. What they're asking is, can we make either one of these trips? So we're gonna call this X, and we're gonna call this Y. And basically what we're looking for is either one of those 42 miles or less. Because if they are, then we could make the rest of the trip. Okay? Let's set up X. What over what equals what over what? Sine 52 over X. Okay, so that's this angle with this side equals what? Sine 58 over 40, okay? And then we'll cross multiply it. So it's x sine 58 is equal to 40 sine 52. How do we solve that? Divide. So we're going to divide by sine 58 and divide by sine 58. Again, this is where you be very careful. Either put the parenthesis in right here or hit enter before you divide. Okay? So 40 sine 52 divided by sine 58. What do you get? 37.1, we'll say 37.2. What? Did you get 0.5? Oh. You good? Okay. So 37.2 miles. Can they make that trip? Yeah. So X would work. This is a big fat yes. Okay. Could they make the trip to Covetown Lighthouse? What's that setup going to be? So now we're solving for Y. What's associated with the Y? Sine 70. Okay, so we're going to say sine 70 over Y is equal to, and then go back to the one we already used, right? Those two, sine 58 over 40, and cross multiply that. So we get 40 sine 70 equals Y sine 58. Okay, and again, we're just going to divide by sine 58. So it's the exact same process, just different numbers. Don't forget your parenthesis here or hit enter. So 40 sine 70 divided by sine 58. You get 44.3. Can they do that one? No. So this would be a big fat nope. Okay?